Hello ladies and gents. In this lesson we're going to demonstrate how to configure a Cisco router to act as a DHCP relay agent. So the first thing we're going to do is to lay down the necessary infrastructure, which will be consisting of a router, two PCs, which are going to connect to a switch, and then finally a DHCP server. So I'm going to call this DHCP server, and then I am going to deploy the necessary cabling. I'm going to fast forward the time a little bit, and next we're going to put a couple of nodes just for us to remember the two networks that are going to be part of this topology. The first one is going to be 192.168.1.0/24, and the second one will be 172.16.1.0/24. We're going to zoom in so that we can see everything more clearly. Drag everything to the center of the screen. Double click the DHCP server in order to assign it an IPv4 address of 172.16.1.254. Subnet mask 255.255.255.0, and then the default gateway is going to be .1 with the same subnet. Okay, and since this server is going to function as a DHCP server, we need to enable the DHCP service, specify the IP address of our gateway, which in this subnet is 172.16.1.1, and let's put a DNS server of 8.8.8.8. The starting IP address will be actually we need to specify the network that the two PCs will reside in, which is 192.168.1.0/24. So the starting IP address will need to be 192.168.1.2, because .1 will be the IP address associated with the interface of the router facing the LAN where the two PCs reside. The subnet mask is just fine, it's the /24 CIDR that we need, and we're going to click on Save. And we are done with the configuration of our DHCP server. Next, I'm going to double click the router, run no, enable conft. Interface gigabit Ethernet. We'll start with the one facing the DHCP server, which is 0/0/0, IP address 172.16.1.1. Subnet mask 255.255.255.0. No shutdown, which brings up the interface, and the other interface should be 0/0/1. And its IP address is going to be 192.168.1.1, 255.255.255.0, and we're going to run no shutdown. We're going to commit our change to memory, and for now we'll close the router's window. I'll fast forward the time, And if I double click our PC, or one of them anyway, and I go to its IP configuration and I switch to DHCP, we can see that the DHCP request failed and a PIPA is being used instead. This is because routers are known to break up broadcast domains. And in this internetwork, we have two broadcast domains. The one that belongs to the 192.168.1.0/24 network, and the second one that belongs to the network between the DHCP server and the router. And since DHCP relies on broadcast requests by the clients in order to get their IP addresses from the DHCP server, and the router is not forwarding by default any broadcast traffic, DHCP failed on our PC. So, in order to make this work, in order to enable these two PCs to get their IP addresses dynamically from our DHCP server that resides in a different network, in a different broadcast domain, we need to configure our router to work as a DHCP relay agent. And to do that, we need to go back into its configuration, and we need to go back to the interface facing the two PCs, and we need to run the command IP helper address followed by the IP address of our DHCP server, which is 172.16.1.254. Save our changes, close the window, fast forward the time to make sure that our changes have taken effect, and let's try again. So back to the IP configuration, and we see that as soon as I went back to the IP configuration of our PC, we can see that this time DHCP worked, and this PC has successfully obtained an IP address from our DHCP server that resides in a different network. We can see its IPv4 address, its subnet mask, its DNS server, and the default gateway is actually wrong, so let me correct that. I'll go back to the DHCP server, DHCP, and the default gateway should be the one facing the two PCs. So 192.168.1.1. Save. Fast forward the time. Go back to the IP configuration of our PC. And what I'll do is I'll switch it from DHCP to static and then back to DHCP, and now our client is retrieving all necessary details such as IPv4 address, subnet mask, default gateway, and the DNS server as configured in the DHCP scope of our server. We are not quite done though yet, because when configuring the IP helper address on the router's interface, we didn't just enable the forwarding of UDP traffic to our DHCP server, we also enabled forwarding to multiple other protocols that operate with UDP, such as TFTP, NTP, CACAX, and several others. And this is not good. As network security engineers, we always aim to restrict our services and disable any unnecessary services, as we understand that they pose security risk and they broaden our attack surface. And so what I need to do is to go back to the router and run enable conft, and whilst in global configuration mode I need to run IP, or actually no IP, forward protocol UDP. So basically what I've just done with this command is disabling the forwarding of UDP traffic through that router. But now what we've done with this is we've essentially blocked the router's ability from forwarding DHCP traffic from our two PCs to the DHCP server. So if I fast forward the time and I go to my second PC, go to its IP configuration menu and switch to DHCP, we can see that once again DHCP is failing because of the last command that we ran. So what we need to do next is to whitelist the traffic only being forwarded for the DHCP server. And for that we need to run IP forward protocol UDP 67 and 68, which are the two UDP ports that the DHCP server uses. Save our changes, close the window, fast forward the time, and if I go back to my second PC, we can see immediately that DHCP is working, that the PC is retrieving the necessary details from our DHCP server's scope, such as an IPv4 address, the subnet mask, a default gateway, and a DNS server, thereby verifying that we have configured successfully our router to function as a DHCP relay agent, whilst at the same time restricting the forwarding of UDP traffic to only our DHCP server and nothing else. Thank you very much for watching.